Hello there and welcome to Learner's Mind. Now today I've prepared you a very awesome video on linked lists, array lists and arrays. We're going to cover this in the shortest time possible so that you can understand the fundamentals of these very important aspects of Java programming. If you haven't subscribed yet, consider subscribing because honestly it will help me a lot. So let's begin. I'm using IntelliJ IDEA, and whatever you may be using, whether you like to use Visual Studio, some people prefer to use NetBeans, it should just work the same. So let us begin, and I'll begin by covering the simplest, which is arrays. They may seem very simple, but sometimes to some people they may be so daunting. Let us begin. In my main class, in my main method, I want to create an array of integers. Now to do that, integer of arrays, and I'll call this numbers. This one is equals to new integer of arrays, and let me say I only need 5 elements in my array. So if I need 5 elements in my array, then there we go, I can put in 5 elements. Now arrays begin, that is the indexing starts at 0, and therefore I can insert element number 1 into my array by saying that numbers and then 0, which means at index 0, let me give that a value of 12. Duplicate 5 times. Now I have 5 elements, 1, 2, 3, 4, 5, and that is because I said I need 5 elements. So just change this one very quickly. So let me quickly change these values like that, and now I have my array. Let us try to print this array and see. And that is why we are at Learner's Mind. We want to see what a learner would have done. Let us try to print that and see. As you can see, it does not print the elements in the array, it prints the memory location. And here we have it, the memory location on the console. What are we supposed to do? Here, for you to print all the elements of our array numbers, we need to loop through. And you can loop through using a for loop. So I'll say for int, very simple for loop, I'll print numbers. Now that one gives me not 0 but passing here the index, which is num. And now here what I need to do is simply sort that. If we run this for loop, we are going to get all the values in our array. So let us try that and see on the console. And as you can see, we have our values down here. That is right. Just as a by the way, we can also use an enhanced for loop by saying for integer num in numbers. So for each integer num in numbers, just sort that now, and this one should also work. So pull out the console and you can see, there we go, we have our values here again. Some people can work it out with while loop, but now that we know the length of our array, we don't have to use a while loop here. We can only apply a while loop if we don't know how long the loop should run. For loop or an enhanced for loop works fine here. You may also convert it to something else and use an iterator, but we'll come to that a little bit later on. So that is it with creating an array, and this is just a one-dimensional array. You can create also a two-dimensional array, and I want us now to look at how we can create a two-dimensional array. Two-dimensional array, if it was in matrices, then you could have something like, now this is a two-dimensional array because it is a 2 by 2 matrix, or we can say it has only 2 dimensions, like it has length and then it has the height. That is two-dimensional. Afterwards, let us try to create that. So we can simply nest an array inside an array, and that will give us a two-dimensional array. So the first thing I want us to do is to create a 2 by 2 array of integers. So I'll say it is something like that. It is an array of arrays, and we can say this one is called numbers still. So what we need to do is actually first of all create these two arrays and then nest them inside an array. So I'm going to have two arrays inside an array, and now I need to put this inside my numbers. So what I'm going to do is say numbers, and the first element in numbers equals to ages, and then numbers, the second element in numbers, I don't know why I can't type numbers, second element, which is at index 1, equals to serious. And there we go, we are done. We cannot print numbers now. Even if we try to print numbers, as we've seen earlier, that if we attempt to print numbers this way, it doesn't happen. It gives us memory location rather than giving us the elements inside our numbers. So how do we go about that? Enhanced for loop. Now that we know numbers is an array of other numbers, we can first of all destructure our array, and then from each, since we know that this is a big array containing smaller arrays, now in this big array, first of all we get the smaller arrays, and then in each smaller array we can now break it down to get those numbers. So that is what we are going to do. So first of all, this for loop destructures the outer array, the bigger array, which contains smaller arrays. Now once we get every smaller array inside the big array, for each smaller array inside the big array, we simply need to get a number inside that smaller array, and then we print that. Fine, and there we go, and we have our numbers here: 23, 11, 45, 65, and that is it. That is what we got from that. With this, we can go ahead and do a lot with these arrays and try to build so many things. For example, represent so many different structures by use of arrays. But arrays have limitations, and the main limitation of arrays is that you cannot extend the size of an array. Once you've created it in memory, it does not allow you to expand it and add more elements. So how do you go about that? That is when we need linked lists and array lists. But the advanced data structures are slower. This is because arrays store elements in contiguous memory locations. That means memory slots which follow one another. So if we use a for loop, then it will not go around the memory searching. The moment it gets to the first one, then towards the end of the first element, that is where the second element begins. So all those elements in an array are stored in memory locations adjacent to each other. Technically, we say those are contiguous memory locations. With the linked lists and array lists, things become a little bit different. So let us talk about linked lists and array lists. I'll simply do away with this. I'll actually comment it out. And now we can go ahead and talk about linked lists and array lists. Now that we've talked about arrays a little bit, we can now move into array lists. Now, why do we need array lists and how are they important? Now, array lists behave similar to arrays. They also store data in contiguous memory locations. That makes array lists faster. But even though they are faster, they are so hungry on memory. The reason why they are hungry on memory is that the moment the first array list gets filled with elements, if we try to add in another element, it will allow us to add in another element because it literally creates another array that is double the size of the previous one. So let us take an example, like we have an array of elements 1 to 3, an array of integers of values 1 to 3. So let me say this was just numbers, and then we have something like this. For example, let me comment that one out so that we can use it as an example. If we have this and then we want to add in another number, let us say 4, then what is going to happen is that since this one has only 3 locations for different elements, 3 elements, the length of this array is 3. Then what we can do is that we will create the array list, will create another new array that is longer, that is actually double the value, the length of the first array. So since this one has length of 3, then the next one will have a length of 6. So if we try to add in just one more element, then if we are using array lists, then it means it will create a new
array with double the size of the previous one, then simply add in 4. So imagine if we have 1,000 elements and then we simply want to add the 1,001st element. Then it's going to create another new array in memory with length of 2,000 just to accommodate just that one more element. And that is why array lists are simply arrays that double their sizes. They are very fast because they also use contiguous memory, but they are very hungry on resources. So that is it. So let us try to use array lists now that we've understood how they work. Now to begin with, we are going to import the class responsible for arrays. First of all, let us just clear that. Now array lists, and linked lists, all of them implement the list interface. So even if I just use like list and then say this is just a list of in generics now here, integer, and then we call it like my array. So when it's equals to new array list, and then there we go, we are done. It says it wants us to import the class, so we'll simply import that class that way. And if you come up here, you'll see we've imported both the list and the array list. List is an interface, and array list is the implementation of the list interface. So from here we can proceed. Some people may also do it this way and just go straight and say array list of type integer and call it like now URA is equals to new array list, like that. You don't have to instantiate it like this, but at least at one point you'll have to do it like this so that you can be allocated memory space. So next we can add elements into our array list, but array list is not like arrays. It has methods for adding elements into the array. So I'll simply say my array dot add. It has an add method for adding elements into the array. So array list dot add, and then I want to add a number like 12. See, and then learner's mind. Let us see what will a learner think if they want to print the elements or the elements from my array. So what the learner will do is try to simply sort everything and say my array. Let us see what happens. And there we go, we get our value 12. Array lists don't have a problem with being printed directly this way. They just work fine. So for a learner's mind, this one works, and good. That's great. Now next, we want to add a little bit more. So I'll simply duplicate this, but then change the values. So we have 13 and have 17 here. Try to print my array again, and there we go. We have values down here on the console. Here we have 13, 12, 13, and 17. So they work fine. Now next, I want us to do something else on this array. Let us look at more methods that we can perform on my array. So just type my array, then dot operator, and we're going to see get. And get helps us to get, actually to retrieve an element from my array list. So what you're going to do is just hover over this formula and see what it requires. It requires an index. That is the only parameter it requires. So we need index 1, which is 13. Let's check that. So I'm going to store this in an integer called let me call it number, like that, and then try to sort that number or print this number. So run that and then check, and here we have 13. Fine, it works well. Now next, let us try out another new method, another different method on array lists, and I simply say my array dot, and this time I want to try and clear what we have inside my array. So my array has 12, has 13 and 17, and now I'm trying to clear it. You see, when you clear, you don't pass any parameter inside this clear method. So our method is done, and now to make sure that everything is fine, that everything has been cleared, let us try to print our array and see what's left in there after clearing it. And as you can see, we end up with an empty array. That's it. And by the way, you can also print dot size. So size gives us the size of my array. So let us check that and see what is going to print. It is 0 because there is nothing in there. Another method that we can perform on our array list is try something like this. So let us check if our array contains 17. So I'll say we need a boolean value because this one will return a boolean value. So boolean like is there. Let me say is there, and then say this one is equal to my array, and then say dot contains, and then pass in the object. Which object do you think it contains? Does it contain 12? Let us check that. Then as out and print out on the console this is there. So let us try is there and see if it is true or false. And as you can see here, it is true. 12 is found in there. But if we try out an element which is not found inside there, like 10, try to run that, then it is false because 10 is not found inside my array. One more method before we move to linked lists is try my array dot and look for another method here, get first. So as the name suggests, this one gives us the first element. So let us get this one is an integer, generally because we're working with integers here. So integer first. If I can type this to right, then try to print out this first and check. Now if you check, yes, there we go, it is 12. And you can also try out dot get last and it should return 17. Get last should return 17. So you can go on and look at more methods on this. Now just like array lists, next I want us to talk about linked lists. Now what about linked lists? Oh, what are linked lists anyway? Let me first of all clear the screen like that, then try to clear let me see. Now what about linked lists? Now in contrary to array lists, so linked lists are also linked, and when I say linked, this means that they are joined by something. So what happens with a linked list is that if I have an object at one point in memory, then another object at another point in memory, those two are linked, and they are linked through memory locations or pointers. If it was in C++ or C, we could have been talking about pointers, and actually here is just the memory address of the next one. So like for example, if you have 3 guys in a city, so the only way to know, and the moment you get the first guy, you ask them what's your name, they'll tell you the name, and then you ask them how can I get to the second member, they have the address of the next member's house, so they simply keep the address of the next member, they give you the address, you use that address to get the second person in that city, and then ask them the name, record the name, and then move on and ask them to give you the memory location, or actually the address of the next person, who is now person number 3. Now that is what happens in an array list. Elements are not simple elements, they are actually nodes in memory. they contain both the value that you are looking for or that you are storing and also an address of the next value on that linked list. So if we store like 5 numbers using a linked list, they'll be spread up all over the memory, but then each element will be in form of a node such that that node will have the value of that element and will also store the address of the next element in the linked list. And that is why linked lists somehow perform like they are not that memory hungry like array lists, because they don't waste a lot of space like array lists, but they are slow because moving from one region to another region of the memory location to look for another value, and then like that traversing through may waste a lot of time, and actually it wastes a lot of time. So but they are very economical with space, because if you look at resources such as space, they are very economical because any point we have a small memory somewhere which is capable of storing a certain value, then that point is going to be used to store the values. So the benefit of a linked list over an array list is that the linked list is very economical when it comes to resources, but then when it comes to performance it is slower. An array list is very optimized when it comes to performance, but when it comes to resources such as memory, not good. Anyway, so let us go to linked list. So linked list also implements the list interface. So we can also use a list to get a linked list out of it. But now this time I just want to use the linked list itself. So linked list, and this time I want to use a linked list of strings of type string, then call it like people. Next, this one, let me just instantiate it like that. And now, just like an array list, we can get almost the same methods. Like now we can say people dot add, and now I can add something like Samuel. And when I do add this Samuel this way, then what happens is, where's the mistake now? Too many characters. Oh, sorry. I've just been using JavaScript and I'm making a mistake here. Java doesn't want that. When you use double quotes is a string, single quotes is a character, like that. So I've added Samuel, and now this Samuel is not simply Samuel, but it is a node that holds Samuel as the value and also a space waiting to hold the memory location of the next value that I want to add. So let us picture Samuel to be somebody with a house, and now in this house we have Samuel in the house, and now the house is the node, Samuel is the value. Now we have Samuel in the house, and we also have some space in this house that keeps the memory location of the next person. Let us say the address of the house of the next person. So let us say people dot add, and now this time I want to add Abdul, and the moment I add Abdul like that, what linked list does, it look for any memory anywhere, then keep there Abdul, and then take that memory location and give it to Samuel, so that now Samuel has the memory location of Abdul. And if I add another one in people, and let me add Shafiq, and now what the array list will do, it takes Shafiq, looks for any memory anywhere, gives Shafiq, assigns it to Shafiq, and then take the location where Shafiq is and give it to Abdul. So simple. That is how a linked list works. And actually you can construct your own linked list by using the nodes. Those are just simple classes. So from there we can simply print that in the console and see what people contains. So run that, and as you can see, it has compiled successfully, and we have Samuel, Abdul, and Shafiq. We can look at more methods on this linked list, and the first one that I want us to check is if it contains. So we can say do we have somebody called Ayub? This one will give us a boolean, so let us have a boolean called is there Ayub in there, and then try to solve that. Is there? No, definitely no, so it is false. Now something else that I want you to think about is, what if I put here Samuel? What do you think? Let me give you 2 seconds so that you can make your conclusion. Will it print true or false? Okay, fine. Let us run that and check. And you got it. It is true. You got it. It is true. Samuel is in there. Now let us clear that. So let us take people and then clear. Methods are very similar here. So let us now try to print people. What do you think will be printed? Again, I want to give you 2 seconds to make your judgment. Fine. So let us run that and see. Yes, you got it. Anyway, you got it, and it's an empty array. Now let us see if we try to get the size of this. So try to print out the size, and what will be the size if we clear people? Definitely it's going to be 0. So it is of length 0, and there we go, size is 0. So you don't get any size after clearing that linked list. Next, let us look at something else and see. Size, we talked about it. We can clone that. Let us get an element. So get element, and then we want to pass in the index of the element, like index 2. And now if you've mastered indices, what do you think this one should get us? Definitely this one should be a string of somebody's name, and then we get people.get. Now what are we going to get? Guess that? Fine, let us see. Put the name, try to print that. Then you see Shafiq is at index 2. So as we wind up, let us look at one last method using this array list. Say people, then let us just look at one last method, index of, and then pass in an object. So what is the index of Abdul? So the index of Abdul will return us an integer. So let me just call it index still, and then try to print that one out. So what do you think will be the index of Abdul? Fine, this is Samuel is index 0, Abdul is index 1, so expect to see 1 on the console. So there we go, and we see 1 on the console. Fine, I'd like to stop there. Kindly remember subscribing and support my channel. That one will definitely help me. Otherwise, I want to wish you a nice time.